This is Linked Data Engineering, and this is part 3 of the OpenHPI course, where you learn to put or to pose more complex SPARQL queries. We have already learned what SPARQL is and how to do complex and even more complex SPARQL queries, and you will see that this, of course, was not the end of the story. There are even more possibilities. So, to learn the next step, just have first a look at the following example. The example here will be, we select all the authors and their notable works and the year of publication from DBpedia. So this is nothing new. So we have a simple query which says select author, work and date here. And of course we do this then from DBpedia, and then you see all the graph patterns. First we say, okay, must be of type DBO writer. Then we select the work, and then the third thing that we select here would be the release date. So DBP release date is a DBpedia property. It's not a DBO from the DBpedia ontology. It's a simple unmapped property. And then you have there the date. And we want to order the result by the date. And we only want to see the first 100. To do this, of course, again, you can here click on this, the link to the SPARQL endpoint, and we do the query, and you see here, okay, there are the authors, their works, and the dates. But you see here, if you look at the dates, oh, this is quite confusing. 2012, okay, this is a year. 2012, then this should be February 7th, for example. Yeah, 2, that's interesting. It seems to be an antique work. But this year, it's really strange. No idea how this came across. So you see, there are lots of different formats. This is, of course, because Wikipedia is in an automated way transformed into DBpedia. And Wikipedia is now database. So the point is it's a wiki. And in that wiki, we have hundreds or even thousands of authors of this in the same article, and they of course are not always familiar or have a consent how to put the date in there. And this is the reason why there is such, let's say, a variety of dates. Of course we want to change this, or we want to have, let's say, a more better readable result. And you will learn how to do that. So in the presentation here, just in case you are not able to access the SPARQL endpoint, I have an example for you how this result could look like. It could look also a bit different because, you know, DBpedia also is regularly updated, and therefore also the results are changing. Also, the methods, how the mapping takes place from Wikipedia to DBpedia is under constant development, and this might also change. So therefore, not all results that are displayed here in the presentation must reflect the same results that you get if you ask DBpedia, because it might be already another version. But it should be quite similar. Okay, so the point is now, let's somehow try to change the way how the date is formatted, and then of course try to achieve an ordered result list. So what we do here first is the following. We try to transform first the variable date to an integer. We do this here simply by putting in front of it on the output variable xsd colon integer. This is the data type integer, and after that, in parentheses, you put the variable, and this variable then is typecasted into another type, into an integer. And then what we do next is, okay, we want to interpret this as a new variable. So because there is an operation performed on that variable, it's not the same variable anymore. And therefore we are assigning it a new name, and the name here should be year. It means we are using the keyword as, and saying the new name is year. So interpret the result of the operation xsd integer of date as year. And now you can use year as the name of the new output variable. This will be displayed in the result list. And you can also use then output operations on it. Like, for example, you can order it according to that column, and you have then the name of the column, which would be year. So what we can do is we can order it in a descending way, for example, by year. Let's have a look at the result. So the result should look somehow like this. You say, oh, there's no years. There is, you have to go to the side. And then, of course, it's descending. So the largest or greatest year is on the top. Oh, this is something strange, as you see here. Rather huge numbers. And then here it starts with 2014, descending 13, 12, 11, and so on, and so on, and so on. But you see here, there are some errors. And we will see how these errors come across. This is simply because of the wrong interpretation, for example, of something which might be written here as a variable. We will see that. Okay, so this, for example, might produce results which look like that. Okay, now let's try to make something even more sophisticated. We can use, for example, a regular expression and string operations which are available in SPARQL. Let's have a look on what we are doing here. So we have a new variable assignment, so the operation that you see here, the result of it will be interpreted as the variable year, and we do a lot of string manipulation there. So let's have a look, what are we doing? We start here in the middle of all these opening parentheses, and we see here, here's the variable date. So first is we want to interpret whatever is in date as a string. And in that string, we want to replace something because there might be something which does not belong to the string. And we are interested only in numbers. We want to have the year, of course. So this means we are using a regular expression and we say replace in this string. Now comes the pattern. The pattern here is given here as a regular expression, and you're using here these square brackets, and in these square brackets you have the regular expression, which means this is a not in a regular expression, and 0 to 9 means replace everything which is not a number, and now behind the comma comes with what is it replaced, and this is nothing. So this is the empty string. As you see here, these double quotes simply say this is a string, and this means regular expression for non-number, so every non-number should be replaced by the empty string. This is the replace. And we are not even content with that, so possibly there are additional numbers. We are interested in the first 4 digits for the year. And this means we are looking at the substring, and the substring from position 1 to position 4. So 1, and the length of the string should be 4. So it's the substring of everything which is not a number is replaced or is cut out. And of course, the date should be interpreted as string. And then, of course, we can, in the end, order it according to that variable. What you see here is an additional filter expression that I have put in here, and of course this is on the variable date, so this is the regular way. We do here filter and say regex for regular expression, and they say on the date do the following please. The first 4 should be, so the first 4 here in curly brackets, the first 4 should be digits. So this is our condition. So select only those dates where the first 4 are digits. We are not interested in the other ones because we think probably it's not a date. Okay, let's try to do that. We query the SPARQL endpoint and look at the result. And the result, of course, is quite interesting, as you see here. Okay, Henry James. And yeah, interesting. The 4 things of Henry James, the ambassadors, it's even here twice. Also the wings of a dove, also twice. So they have not even published. They will be published in 4,000 years, which means there must be some other kind of error. But then here at 2015, it starts to make sense. So these are then works that have been published 2015 or earlier, and our filter condition that we have specified seemed to have somehow worked. Now the question is, why is there a problem with Henry James, the ambassadors, or the wings of a dove? No idea, but we can have a look at it. So simply here click on the ambassadors and you will end up in the DBpedia page of the ambassadors. And now we have to look at the release date. So let's find release. So here is the release date, DBP release date. And what you see here, yeah, of course, this is, as a human, you can read that this is a date, of course. And as a human, you might also directly deduce from what is given here that this is the release date of the book at Harper's and then the release date of the book at another publisher. For example, here, Methven. In Methven, it has been published in September 1903, and at Harper's, it has been published in November 1903. But the point is, if this string is translated with our regular expression, what happens is we are starting here, November 6, and then it should be 6/11 and so on, or something like that. So the point is, this is in the year 6000, this is in the year 2400 or something like that. So in the end, if this is interpreted somehow, the result will be wrong. Simply also because the year we are looking for is not in the first place. It's not formatted like a proper date expression. It's formatted here in a special way. So therefore here the year is on the right side, and therefore our regular expression was not able to catch this correctly. But this is an exception. Usually it should look in another way. Let's go back, for example, if we go to that one, hologram for a king, and we look for release date, and you see here June 2012, so this is also not correct, but in the end, so what's the release date that we find here? It's 2012. So here it was possible to read the 2012 in the correct way. You can play around with that, of course. Feel free to do that. And we will continue with more complex queries in the end. So usually what you will see in DBpedia, data is not always 100% reliable. Most times it's 90, 79 or 97 or 98% reliable that way, of course. But there are a few outliers which result from, let's say, bad mapping procedures or by errors and failures made by the authors of Wikipedia, for example, that there are, of course, errors in the data. And the point is, if you find out about these errors, you have to correct them, not in DBpedia, but in Wikipedia, because DBpedia is always created from Wikipedia. That's the point. Okay, let's switch to another topic. There are more functions that you can use in SPARQL, the so-called aggregate functions. So these are also output-related functions. And you see here what you can do, for example, if you want to know how many authors are there in DBpedia. Of course, you can select the authors, everything which is of type writer, and then count the result lines by yourself. But there is also an aggregate function similar to SQL. There is also the same aggregate function. You can say select, count, and then you say the name of the variable which should be counted. And this is then here author. And what I do here is, of course, I assign it a new name, or so as number, I say this variable should have a new name. And then I have simply my select statement as before, where I say where author RDF type DBO writer. So this is a simple graph pattern. The point is, the result will not be each single line, but the lines will only be counted. Let's try it out. So we click here and you see here that's of course the newly assigned name of the variable. It's num, short for number. And this is the number of lines that should usually be returned. So there are 29,835 authors represented in DBpedia, which have the RDF type DBO writer. Which does not mean that there are no other writers in DBpedia. The only thing what it means is that the class membership to DBO writer is only given by 29,000 of them. Okay, but this is something you might find out about the data if you try to further explore it. So this was an aggregate function. But there are even more aggregate functions. What else can I do? I can, for example, also apply aggregate functions on so-called groupings. What are groupings? Let's assume, for example, you want to know which author wrote how many notable works, simply to compare the number of notable works written by authors. What you do here is you aggregate then all works of one author and count the resulting lines. And this is be done then via a group operation. So let's have a look how it works. You have two aggregate functions. First, of course, you want to count works as before, but what you are doing, you just try for the first output variable you have here, which is author, you try to aggregate everything also according to author, which means you subsume, you aggregate all results which belong to one and the same author. You do this by group by. And then as it's the second output variable, you do another aggregation over all the works of these authors and say, okay, let's count them. And this is then the variable number of works. That's that one. Let's have a look here. We are selecting author and then the count of their works, where author is of type writer, so this is an author, and the author has a notable work, which is work. And then in the end, we try to order this simply in a descending order, starting with the author who has the most notable works, so descending order. Let's try it. And we see here a list of authors, starting with somebody who is called Julian Stockwin. And then, yeah, probably you will know Roald Dahl, Willy Wonka, Charlie and the Chocolate Factory, possibly. Somebody else, Agatha Christie, of course, you will know, Samuel Beckett, you will know. So these are not all the works of Agatha Christie. These are only 10 notable works of Agatha Christie, which are represented in DBpedia, and which of all of their works have been the property that they are notable works, according to the authors of Wikipedia. Okay, who is Julian Stockwin? Let's have a look at his notable work. So this is Julian Stockwork, and now here we have the property notable work, and you see here all the works. So he's writing novels, so it looks like, so Conquest, Stockwin's Maritime, Miscellany, Tenacious, and stuff like that. So I don't know this author, maybe you know him. Let's have a look. When he's born, 1944, so must be or should be still living author. If you know about Julian Stockwin, tell me in our discussion list. Okay, and of course you can then continue this list. And you see we have put no limit in here, so this will be 29,000 authors and their notable works in the end. Okay, so this was another aggregation function. So we see the result also here in the presentation. Next, what we can do, we can, of course, if we aggregate with a group by constraint, we can put another constraint on it that we say, I do not want to aggregate all the authors, but only authors who have a specific property. So for example, I want to say only authors who have written more than 3 works, which then would be, I have a group by author, and again I have also this count work, but I only consider groups of authors where they having this count of work equal 3. So I only consider authors who have written exactly 3 notable works. And we click on the query. And let's try it out. And you see here the result will be, in the end, all authors who have written exactly 3 notable works. Maybe you know Alexandre Dumas. So let's see what notable works he has written. Of course, the 3 Musketeers, 20 years after, and the Vicomte of Bragelonne, 10 years later. So the Count of Monte Cristo is not with it, but maybe in the next revision of DBpedia. Okay, so these were possibilities of aggregate functions, as you have seen here. There are even more. So SPARQL 1.1 provides several aggregate functions or aggregation functions. First of all, if your results, for example, are numerical, you can sum them up, simply add them on, build the sum of it. Or you can compute the average of your numerical results. And you can compute the minimum or the maximum over all returned results. Two special aggregation functions are sample and the group concatenation. What means sample? Sample means simply I pick one of the results in a non-deterministic way, so simply by random. So just pick one. I'm not interested in all of them. And group concat means in one variable put all the results, but interpret them as a string and concatenate them. And of course, with this you can also define a designated string separator with which the different results then will be separated. Let's have a look at that. Okay, so the task now in this example is we want to compare an arbitrary title of a notable works of an author with all the non-English titles. How do we do that? An arbitrary title we can pick simply with the aggregation function sample. So you will see here in the select statement first we select a sample of the title and we give this then here the variable name name. And the second one we do a group concatenation also from the title, but not to choose the same one, we want to choose another one, so exactly the same, but we use another variable for that, which means the alternative names, which are all names, which are present here under the RDFS label constraint. Therefore, first variable title, there is the title of the work. Next variable alt titles, which means all titles you have also for the work. Why we have to do that, you should think it over, and of course you can discuss it in our discussion list. Otherwise, if you leave this out and simply do it with title, what happens then? Try it out, you will see. Okay, let's get back to our task. So sample title means an arbitrary title, and group concat of all alternate titles, which are also all titles which are here, then means all the titles that are available in all languages. They are simply concatenated one after the other, and we have a string separator here which is a comma and an empty space, so to separate them. And this, of course, the string separator also has here to be written in quotes, in double quotes here. And this one then will a new variable with the name alt names. Okay, what else do we do? In the alt names, we won't only have names which are written somehow in English, that's interesting. And this should be then grouped by the author. It's clear, we group by the author right in the beginning, and then from all the notable works which are there, we want to have one sample, and we want to have one group concat of all the available names. So this is already a rather complicated aggregation. Of course, it's somehow created artificially. Okay, let's see what happens. So this again is the query at the dbpedia SPARQL endpoint, and I run the query. And you see here the result. So the first column will be the names, an arbitrary name. This can be English or any other language name. So here you have Italian, or another thing you have here, for example, Arabic, and what else do you have? You have here Spanish. And the second one here, the second one are all the other alternative names which are recorded somewhere at RDFS label for exactly this notable work. And this can be, of course, in any arbitrary language which is available in dbpedia. Okay, another thing I wanted to show you. So you see here the result. Let's go one back. Of course, in the filter condition, there is a non-equal, which means we filter exactly those alternative titles, or we will only want to include those alternative titles which are not English, not the English titles. So this is another sophisticated refinement of this constraint, of course, a bit artificial. But this, of course, are aggregation functions. And now you know how to aggregate SPARQL results. What else do we want to do? In the next part of the lecture, you will learn another operation in SPARQL, which means you can combine two SPARQL queries by so-called SPARQL subselects, by subqueries. And there is something else really nice for the graph traversal in SPARQL. You can define property paths. So not only a triple, but for example, for a property, you can look for entire paths. So combine more properties with each other. How this works, you will learn in the next part of the lecture.